Now let's study 3NF, third normal form, 3 normal form. Now in this 3NF, what will happen? In this 3NF, remember in 2NF we are saying this. If you notice, a relation R in 2NF, this we already know. A relation R is in 2NF. What we are saying? A relation R is in 2NF if no non-prime attribute is partially dependent on any candidate key. Yes or no? This is what we say, correct? Okay. Anyway, now the same definition for 3NF. If I go for 3NF, then this partial will be replaced by transitive. That's it. This is the only change. This is the only change. Is this clear? A relation is in 3NF if no non-prime attribute is transitive dependent on any key. No non-prime attributes transitive dependent on any key. Or I can say that every non-prime attribute, what should happen? What should happen with every non-prime attribute? Every non-prime attribute is non-transitive dependent. Is non-transitively dependent. Is non-transitively dependent on every key. On every candidate key. This is the definition of 3NF. Basically, the problem in 3NF, the violation of 3NF, when it will happen? The violation of 3NF, when it will happen? It will happen in this situation. It will happen in this situation that some candidate key transitively determine. Some candidate key transitively determine some non-prime attribute. Some non-prime attribute. In this situation, the violation will happen. Okay. In this situation, some candidate key transitively determines some non-prime attribute. In this situation, violation will happen. But this is not easy to check. Can you notice? Can you notice this is not easy to check? It will take a lot of time. If you check like this, yes or no? If you check like this, it will take a lot of time. So this definition, remember, in the GATE exam, there are many questions. I will take all those questions. In GATE exam, there are many questions on this definition. So while solving the question, you don't need to apply this definition. When you are solving a question, you don't need to apply this definition because this definition will take a lot of time. We will see equivalent definition. For 2NF, we have seen equivalent definition, yes or no? For 2NF, we have seen two equivalent definitions. Equivalent definitions we have seen. Similarly, for 3NF, we will see equivalent definitions. One of them is very easy. One of them. But all these definitions, in the GATE exam already, there are many questions. 5 or 6 questions are there in the GATE exam where this statement is given as a true-false statement. So this is the violation of 3NF. Violation of 3NF means some candidate key transitively determining some non-prime attribute. Okay. Now, let me tell you that when violation of 3NF will happen, it is very easy. When violation of 3NF will happen, it is actually very easy. When you have this FD, for example, not a super key. Here, not a super key. If something is not a super key, can it be a candidate key? If something is not a super key, can it be a candidate key? No. So this is the violation. Remember, violation of 3NF will happen when not a super key implies non-prime attribute. This is the violation. That's it. It is very easy to check, yes or no? This is quite easy to check. Not a super key implies non-prime attribute. This functional dependency. This functional dependency is violation of 2NF. Why? Tell me why this is like what it has to do with transitive? What this has to do with transitive? This is a simple question. Why this is violation of 3NF? Like, what is transitive here? Remember, this is the definition. Some candidate key transitive determines some non-prime attribute. So this is the definition. This is the definition. Now I am saying that this is what I am saying. I am saying that this is violation. Not a super key implies non-prime attribute. This is violation. Why? So let me give you the proof. Because if this happens, then this will happen. The proof idea. What is the proof idea? The proof idea is this. If this happens, not super key determines non-prime attribute. Non-prime attribute. If this happens, then this will happen. What will happen? If this happens, then this will happen. And if this happens, then this will happen. So basically what I'm saying, then this will happen, that some candidate key transitively determining some non-prime attribute. Okay, are you getting my point? Again, these two things are same basically. If this happens, then this will happen. If this happens, then this will happen. How can I prove it? This is very easy to prove. See, if you have this type of situation, let's assume that this alpha is not a super key. Let's assume. Okay, and let's assume this A is a non-prime attribute. This is a non-prime attribute. Okay, this is a non-prime attribute. Now tell me one thing. Can alpha determine some candidate key? This is my first question. Can alpha determine some candidate key? Can alpha determine some candidate key? Why no? The answer is no. Why? Because if alpha is determining some candidate key, then this will become super key. Because if alpha determines some candidate key, then alpha becomes super key. So alpha cannot determine candidate key. Agree? Okay, yes or no? Now very simple. Now if you have this, okay, if you have this functional dependency, if alpha goes to A, then what will happen? If this is there, then what will happen? If this FD you have, where not a super key implies non-prime attribute, then what I can say? Then what transitive dependency I can create? Then I can create this transitive dependency. You take a candidate key, implies alpha, implies A. Alpha cannot imply CK, yes or no? Alpha cannot imply CK. Is this proof clear? Tell me. Did you understand this proof? Very simple. If you have this type of situation, see, if you have this type of situation where not a super key, if you have this type of situation where not a super key implies non-prime attribute, then you can create this type of transitive dependency. If this happens, then you can create this type of transitive dependency. Is this clear? This is your transitive dependency. CK to A. Yes or no? Is this clear? This is your transitive dependency. Let me know, did you get it? Anyone has any doubt? Okay, let me ask you a few questions. Just tell me this question. Some simple questions I am asking you one by one. Okay, you tell me. This non-prime attribute, let's assume non-prime attribute A determining non-prime attribute B. Is this a problem to 2NF, 3NF? Is this a problem to 3NF? Is this a problem to 3NF? Is a problem to 3NF? Can you prove it? Take copy pen. Nikhil, Yuvraj, Ekta, all of you, take copy pen. Can you prove it? Why this is a problem to 3NF? Non-prime attribute determining another non-prime attribute. Is this a problem to 3NF? Yes, this is a problem. You can notice this is a problem. The answer is yes. The answer is yes. The reason one, I can give you many reasons. For this, I can give you many reasons. But what is the reason number one? The reason number one is very simple. This is not a super key. Or just see, this is not a super key. Reason number one is very simple. Reason number one is very simple. This is not a super key, right? Yes or no? Reason number one very simple. This is not a super key. Because non-prime attribute can never be a super key. Correct? Not a super key implying non-prime attribute. Not a super key implying non-prime attribute. This is the problem. And this is the problem. Yes or no? Tell me, did you get it or not? Not a super key implies non-prime attribute. This is a problem. What is the another reason? What is the reason number two? Can you give me transitive dependency? Can you give me transitive dependency? There is transitive dependency where candidate key is going to non-prime attribute. Can you give me this type of transitive dependency? My question is, can you give me this type of transitive dependency? Yes, you can give, very easy. Because if you have non-prime A to non-prime B, if you have non-prime A to non-prime B, then what I can say, I can very easily give a transitive dependency where basically take the candidate key, that every candidate key can determine A is determining B. Because this is non-prime attribute, so it cannot determine CK. Because this is non-prime attribute, so it cannot determine CK. Picture perfect. Yes or no? Picture perfect. So here what if? So here who is transitive? Tell me. So here I can say candidate key, and this is non-prime B, and this is transitive dependency. Okay. So this is the transitive dependency. Are you understanding these things? See, at the last, you can by heart also. All these things you can by heart also. Like in the 2NF, I gave you the conclusion, right? In the 2NF, I gave you the conclusion. The last two slides. In the 2NF, the last two slides, you can by heart them also. But if you understand, then you can handle any type of question. Whatever question they can create, you can handle. Tell me, did you understand? Like, are you understanding these things? See, everything I'm giving the proof. Everything, for everything I'm giving the proof. Like non-prime attribute to non-prime attribute, this is a problem. But why this is a problem? Many students, they by heart it. Many students, okay, what they will do, like for example, what happens, like the teacher will write few things, okay, 4 or 5 things he will write, and the students will by heart, okay, this is a problem, non-prime to non-prime problem, this to this problem, this to this problem, okay, so these are the problem. So like this, students will by heart, and when you by heart, then many good questions can be created in the GATE exam. We will see, already there are good questions in the GATE exam. There are 5 or 6 good quality questions, okay, so we will see those questions. So don't by heart. Are you understanding everything? Tell me. Like this non-prime attribute to non-prime attribute, why this is problem to 3NF? Why this is a problem to 3NF? Because there is a transitive dependency from candidate key to non-prime attribute. Yes or no? When you have non-prime to non-prime, then very simple, they see non-prime to non-prime. Why this is a problem? Why this is a problem to 3NF? Because there is a transitive dependency from candidate key to non-prime. Okay, is this clear? Anyway, now tell me. So this was question number 1. Now let me ask you question number 2. Is this a problem to 3NF? Is this a problem to 3NF? Is this a problem to 3NF? This is never possible. This is never even possible. This is never even possible. This is never possible. This FD is never possible. Let me give you the summary. This is quite easy. This 3NF. So 3NF summary. What is the definition? Tell me. What is the definition? The definition is very simple, that a relation is in 3NF if every non-prime attribute, tell me, if every non-prime attribute, what should I write? If every non-prime attribute is non-transitively dependent, on every key, on every candidate key. Is this clear? Tell me, yes or no? Non-transitively dependent. Every non-prime attribute is non-transitively dependent on every candidate key. Okay, these words are very important. Every non-prime attribute is non-transitively dependent on every candidate key. I can also say that no non-prime attribute is transitively dependent on any candidate key. I can also say this. Yes or no? I can also say this. What is the another definition? The another definition is this. Another definition. Definition number 3. So definition number 1, definition number 2, definition number 3. What is the definition number 3? Relation R in 3NF. Relation R in 3NF if no functional dependency, no FD of the following form. No FD of the following form. Like this type of FD should not be there. Which type of FD? Tell me. No FD of the following form. You should not have any FD of the following form. Which form? Tell me which form. No FD of the following form, where non-super key determines non-prime attribute. Okay, is this clear? So this, okay, so no FD should be like this. Just understand this, that's it. You don't have to remember all those different things. Is this clear? Just this one thing is enough. Non-super key determining non-prime attribute. This is enough. This same thing you can write in many different ways. So what are the 3NF violations? What are the 3NF violations? What are the 3NF violations? In one word, if you want to write, then this is the violation. This is the violation if you want to write in one word. Not a super key imply determines non-prime attribute. Okay, so this is the problem. If you want to write the same thing in different ways, then you can write like this. Non-prime to non-prime is a problem. Okay, known prime to another known prime. This is a problem. This is a problem. And why this is a problem, you already know. Yes or no? Why this is a problem, you already know. Because this is not a super key. Not a super key implies non prime. So this is a problem. Next you can notice proper subset of candidate key determining non prime. Why this is a problem? Why this is a problem? Because this is not a super key. Proper subset of candidate key cannot be a super key. Yes or no? Are a proper subset of candidate key. This is not a super key. This is a problem in 2NF also. This is a problem in 2NF also. So problem of 3NF is also, so remember, problem of 2NF is also problem of 3NF. Also, you can say, for example, maybe prime plus non-prime, prime plus non-prime, determining non-prime, prime plus non-prime, determining non-prime. Must, okay, it must be not super key. Must be non-super key. Must not be super key. Must not be super key. Okay, so these are some ideas. Okay, so these are some 3NF violations. Can you notice in all these violations, RHS has non-prime attribute. In all these violations, RHS has non-prime attribute. RHS has non-prime attribute in all these violations. So basically, remember, we don't care about the prime attributes. The prime attribute may or may not be transitively dependent on candidate keys. Let's see some examples. With example, this concept will become more clear. Let's see some examples. Mavit is asking, can we say combination of non-prime and prime? Non-prime attribute is non-prime attribute. Is combination of non-prime attribute cannot determine prime attribute. Mavit, combination of non-prime attribute cannot determine prime attribute, but combination of non-prime attribute can determine non-prime attribute. Okay, like combination of non, here it can happen. Here you can have non-primes. Okay, here you can have non-primes. You can have multiple non-primes also, no problem. Okay, next. So now let's see this question. Tell me which is in 3NF. Which is in third normal form. Let's check it out. Let's see the first one. Tell me about the first one. Is this in 3NF? So first you find what are the candidate keys. What are the candidate keys? Here, A to B. We have already done this. Please check your copy. Please check your copy. What is the candidate key here? So you can notice B. B, A, C, D. Yes. So that is B. So now tell me, this is your candidate key. Okay. So definitely this is in 2NF. Definitely this is in 2NF. Yes or no? Definitely this is in 2NF because you have this single attribute candidate key. Because it is simple candidate key. Because it is simple candidate key, so this is in 2NF. What about 3NF? What about 3NF? Tell me what about 3NF? Look at this. This is the violation of 3NF. Yes or no? This is the violation of 3NF. Look at this. Look at this. Violation of 3NF. Violation of 3NF. Why? What is the reason this is violation of 3NF? Because non-prime. Determining non-prime. So this is violation of 3NF. So this relation is not in 3NF. Okay, this relation not in 3NF. The same question, how will you solve using transitive dependency? The same question, how will you solve using transitive dependency? Where is transitive dependency? Do we have this type of transitive dependency? Do we have this type of transitive dependency? Tell me. Can you give me this type of transitive dependency? Yes, there is this type of transitive dependency. This is method number 2. This is method number 2. Can you give me this type of transitive dependency? Yes. So basically determining C. This is transitive, right? B determining C, that is transitive. Agree or not? B determines C, that is transitive. This is a candidate key. This is non-prime. So this is not 3NF. So your relation is not in 3NF. Okay, your relation is not in 3NF because you can notice B can determine A can determine C, A cannot determine B. Picture perfect. The diagram. So this is transitive dependency. So who is transitive? B determining C. This is transitive. Is this point clear? Tell me. Alternative method. This is alternative method. So you can also check transitively. So you can either check like this. Either you can check like this or you can check like this. Both of them, did you understand? Did you understand both of them? Either you can check like this, non-prime to non-prime. This is the violation of 3NF. This is a violation of 3NF. Or you can check like this. This candidate key to non-prime. This is a transitive dependency. So you can check like this. Okay, let's see the next question. Tell me about the B, option B. What about option B? So what are the candidate keys for option B? For option B, what are the candidate keys? So I think AB is the candidate key. AB is the candidate key. BD is the candidate key. BC is the candidate key. So these are the candidate keys. So there is no non-prime attribute, right? There is no non-prime attribute. So can we have any problem? There is no non-prime attribute. There is no non-prime attribute. So no problem. So 3NF. So 3NF. So there is no violation. So this is 3NF. Okay. Next. What about the next? Option C. What about option C? What is the candidate key? A, B, C. C, A. So the candidate key is C, right? The candidate key is C. This is the candidate key. So now tell me. So because of this, this is in 2NF. So R is in 2NF. Now tell me about that 3NF. What about 3NF? Can you notice this is the violation? In front of you, you have the violation. This is the violation of 3NF. This is the violation of 3NF. Okay. This is the violation of 3NF. So 3NF is much easier actually. Yes. This is violation of 3NF. Why? Because non-prime determines non-prime. Non-prime determines non-prime. So that is the violation of 3NF. Okay, this is your, so I can say this R is not in 3NF. Not in 3NF. Can you check this same? Is there any transitive dependency? Yes, this is the transitive dependency. Like for example, what I can do, I can say C determining B. This is transitive dependency. Agree or not? This is transitive. This is transitive dependency where this is the candidate key, this is the non-prime attribute, and this is the candidate. So this is a picture perfect. Again, you will get the picture perfect. So this is your method number 2. You can check like this also. What about the next? What about the next? What about D? What is candidate key? For option D, what is candidate key? A, B, C, D. Okay, so there is no non-prime attribute. If you check what are the candidate keys, in this, the candidate keys will be like this. I think BD will be the candidate key. You can check it out. BD, AB, AC. BD, AB, AC. No non-prime attribute. There is no non-prime attribute. So 3 enough. So this is in 3 enough. There is no problem. So this is in 3 enough. So did you understand 3 enough? Checking 3 enough. Did you understand? Please tell me. Did you understand how to check 3 enough or not? If a relation is in 3 enough or not, how to check that? Okay. So now let's take a small break. After the break, we will continue and we will study BC enough. Then we will solve those nice 5 gate questions. I told you there are 5 gate questions. Very nice gate questions on these true false statement. I told you, yes or no? There are 5 gate questions which are true false statements. And let me tell you that if you understand the correct concept, then only you can solve them. You will be surprised what will happen. See, many students, they have misconceptions. Basically, they study wrong concepts. Okay, from some coaching institute, they will study some wrong concept, and then it is very surprising. I will give you this paradox. I will give you that it is very surprising that they are getting the correct answer. It is very surprising because I will give you the paradox. I will give you the paradox that for one question, your logic does not apply on the another question. For this question, your logic does not apply on this question. So there is a paradox, right? And this paradox is because you have misconception. Yes or no? This paradox happens because there is wrong understanding, or I can say misconception. If you understand the concepts in a right way, then this type of paradox will not happen. So anyway, after the break, we will study BCNF, and also we will solve those 5 questions. Those 5 gate questions we will solve, and I will prove it to you that that so many students, they study wrong concepts, and gate exam is asking a very good questions. Already 5 questions have come. Like, it's not like these questions will come. It's not like sir Deepak sir is teaching a high level, it is not required for gate exam. I will tell you those 5 questions are based on what we have seen. Everything that we have seen, those 5 questions are based on these concepts. Okay, like concept of partial dependency, correct definition of partial dependency, correct definition of transitive dependency, correct definition of 2NF, correct definition of 3NF. You must understand. Then you can solve those 5 questions. Okay, so let's take a break. After the break, we will continue.